Okay, well, it's good to see everybody again. I do apologize about yesterday. Hopefully, everybody got my email or at least saw what I posted to the website. It was actually late afternoon on Monday when I got an email basically stating, "Oh yeah, by the way, you have professional development tomorrow." So that is, I had to scramble to get everything done. But how did everything go? Good. Okay, fantastic, fantastic. So because of that, I'm going to go ahead and push back the deadline for the first exam. So now the exam one retake from last week, you have until this coming Monday morning, the 15th. Okay, so if you need to maybe take it somehow during the day on Friday, it can't be after school because I don't have those on Fridays. But it does give you through the weekend to maybe prepare a little more. You have till Monday morning. You just got to turn in the right triangle trig and the angles and their measures. Yes, sir. My conference period is first period. Okay. So we are gearing up for a quiz tomorrow. I want to go ahead and introduce you to tangent today, start the other trig functions. But once we finish that, we'll go ahead and take a look at the assignment. Last class, I think, ended up with like 23, 24 minutes left. So a decent amount of time to go ahead and look at the homework. And then tomorrow we'll have our quiz and we'll continue the notes. And then don't forget Friday, we got a secure drill, 7th period. Okay, well, let's go ahead and take a look at this sheet first. Now, that lesson over graphing sine and cosine, I really like it the way it presents a lot of the material. It just doesn't talk about the frequency. So we've talked about the amplitude, the period, the phase shift. We have the midline that we talked about recently, but not the frequency. So that's why I put together this little sheet for you. The frequency of a sinusoidal function is the number of cycles the function completes in a 1-unit interval. So what that means is it's the number of cycles, the number of times it repeats in a given radian measure. What's nice about this, it's the reciprocal of the period. So a couple of differences here. It does have the absolute value, which means we have to have a positive number of repetitions. So we really don't need to worry about that. I know that with our period, we said the expression was 2 pi over b with a capital B. So the fact that this is a lowercase b, don't let that bother you. Okay, we're just going to flip it. We'll be able to find it. Okay, so let me give you an example. Does anybody recognize this graph here? That's the graph of what? That's the graph of sine. Okay, so this is just sine of x. Okay, so would everybody agree in this case that b is 1? There's no horizontal dilation. Okay, so let's go ahead and figure out the period. I'm just going to say P for period and F for frequency. Okay, so the period is 2 pi divided by B. Well, that's 2 pi over 1. Well, the period is just 2 pi. So it's going to need 2 pi radians before it starts to repeat again. Well, the frequency, remember, is just the reciprocal. So this is B divided by 2 pi. So 1 over 2 pi. And I want to go ahead and point this out because I see this every year when we first talking about this. You want to make sure to have pi in the denominator. So if I were to write 1 over 2 pi as 1/2 pi, that is something completely different. Okay, so please make sure you have pi down in the denominator. But here's what it means. The numerator is the number of cycles. That's the number of times it's going to repeat. Okay. The denominator is how many radians it's going to need for that number of repetitions. So this is telling me that we should have 1 cycle, 1 repetition in 2 pi radians, and that's exactly what we have. Because once we hit 2 pi, then it starts to repeat again because it's periodic. Okay? So that one's okay, but let's go ahead and try another one of these. Let's look at this one. Now, this one is already transformed. It tells me that this is sine of 3x. Okay. So would everybody agree that b is equal to 3? Okay. Now, what do we do to the parent here? Was this a horizontal stretch or a horizontal shrink? Why shrink? It says 3. Ooh. Oh, you're on the right track. Not the opposite, the multiplicative inverse, so the reciprocal, yes. Okay. When you multiply by x, you've got to take the reciprocal. So the reciprocal of 3 is 1/3. That's your true scale factor. That's why the graph on the left side, we horizontally shrunk it by a factor of 1/3. Okay, so let's go ahead and find the period. Okay, so the period is 2 pi divided by b. And we just said that b is 3. So that's 2 pi over 3. So it takes 2/3 pi, 2/3 pi radians for it to complete one cycle. Okay. Now let's take a look at the frequency. I'm going to flip this, b over 2 pi. So this is 3 over 2 pi. Remember, I still have pi in the denominator. What is this telling me? How many times should this repeat? What do I have up top? So it should repeat 3 times. How many radians should it take to do that? 2 pi radians. So let's check it. Let's start here with 0. Okay. So I'm going to go ahead and go through, there's one cycle. Because at this point at 2/3 pi, it starts to repeat again, right? So now I have a second cycle, a second repetition. And let's go ahead and do this one more time. And you'll notice, where am I at? 2 pi. Okay. See, it repeated itself. We had 3 cycles in 2 pi radians. That's what the frequency is telling you. Is everybody okay with that? So that's the only new item from today that's going to be on that quiz tomorrow. I am going to ask you to go ahead and find the frequency as well. That's easy. It's just the reciprocal of your period. Okay. So with this in mind, boom, 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 we have all those others that I mentioned. Remember, the amplitude is the absolute value of A. The period is 2 pi over B. The phase shift is C divided by B. The midline is Y equals D. And then, of course, we just saw the frequency, B over 2 pi. So you're going to want to be able to recall those expressions for tomorrow. I'm going to have you find these characteristics for some kind of sinusoidal function. Okay, so I'll leave that up there because we got some folks copying. I think it was a different teacher every time. Who was in here yesterday for your class? It was just a coach? You don't know the name, though? Okay. Okay. Cool. Okay. Maybe a few more seconds. And we'll go ahead and let's start. Okay. So the graphs of tangent, cotangent, secant, and cosecant, they are periodic as well. They're going to repeat over and over again given a certain radian measure. Now, however, tangent and cotangent, they're going to have a shorter cycle or period than the other 4 functions. What you're going to find is that tangent and cotangent, they have periods of pi radians. So it's only half a revolution. You got a full period for tangent and cotangent. Now, all 4 of these graphs are going to have something in common. They got something that sine and cosine don't. They're going to have asymptotes. Okay? There's going to be locations where if I plug a radian measure into them, it's not going to be defined. Okay? So before we go ahead and start looking at tangent, here is the sinusoidal function with respect to tangent. See, I got tangent right there in the middle. But A, B, C, and D, they still represent the same transformations that we looked at before. A is your vertical dilation. B is your horizontal dilation. C is going to help you with your phase shift. And then D is going to be the vertical shift. And then again, all those can help you with the characteristics. Now, remember, if your value of B has been multiplied through whatever expression you have, you've got the value of C right there. But if B has been factored out, then you actually have your phase shift. In fact, does that C over B look familiar? Remember, C over B is the expression we use for the phase shift. Okay. All right. Well, how are we going to go ahead and graph tangent? There's a lot of different ways, but we're actually going to use a previous graph to help me out with this. So I'm going to go ahead and say tangent of theta equals. Does anybody remember its ratio? I always forget. Y over x. Now, here's where we're going to use a little bit of substitution. Okay. What trig function is y? Remember, that's sine. Y is your sine function. So I'm going to go ahead and say sine of theta. What trig function is x? That's cosine. So using this ratio, I actually see one of our first identities. Tangent can be rewritten as sine over cosine. But here's the thing. I want to go ahead and focus all of my attention on cosine. Because what's the one thing you cannot divide by? You can't divide by 0. That's where it's undefined. So any theta value, any radian that I plug into cosine, if it becomes 0, that's a big problem for tangent. Okay, so that's why I'm going to start by sketching cosine. So we're going to do this really light. Okay, remember cosine starts with a maximum. Then we had a 0, a minimum, a 0, maximum. Then I'm going to go ahead and do this in the other direction. Okay, so remember, this is just going to be a nice, light, curved line, or curved function, I should say. Curved line. Well, for example, any place that cosine is touching the x-axis, like for example at pi over 2, if I plug pi over 2 into cosine, I'm going to get 0. And you can double check this on the unit circle. Okay. This is going to be an asymptote because we can't divide by 0. So anywhere cosine touches the x-axis, we've got ourselves an asymptote. So I've got one here. Where's another location? Ooh. Now remember, where does the curve touch the x-axis? 3 pi over 2, so that's another one. Then we have another one at -1/2 pi, -3 pi over 2, and this pattern is going to continue forever. Okay. So now that I know where those asymptotes are, we're already done with cosine. We don't need it anymore. So thank you for helping us out. It's gone. Okay. Now we're going to do this a little different. I'm actually going to go ahead and show you the graph of tangent, and then we're going to go ahead and compare it to the unit circle, kind of backwards of how we did it with sine and cosine. Now, between each pair, exactly midway between each consecutive pair of asymptotes, they're going to have an x-intercept. So what's halfway between -pi over 2 and pi over 2? 0. So that's an x-intercept for tangent. Between pi over 2 and 3 pi over 2, that would be pi. And we're just going to continue this over and over again. Now, the one we're going to focus on is this one right here in the middle. So we've got this point here at the origin 0, 0. Okay. Everybody's okay with the x-intercepts? Now, I'm going to go ahead and provide you a couple of other points. What is halfway between 0 and pi over 2? That would be pi over 4, right? So we also have the point pi over 4, comma 1. So pi over 4, comma 1. Okay, we're going to go to -pi over 4, -1. That's going to be another point. -pi over 4, -1. Now, on each of these branches, as we're going to call them, all we're going to have is 3 points to work with. So I'm going to start at the bottom left. I'm going to curve up through these points, right up to the asymptote. That's one period for tangent. Okay. Now, what we're going to use here, our symbol for an asymptote, we're going to use the no solution symbol. Okay. So it starts with an asymptote. We have these 3 points, and then we're bound by another asymptote. So we're looking at this one right here in the middle. Everybody's okay? But you remember, it's like I said with a rubber stamp. If I had that, I could just do it over and over and over again. You're going to see this forever in both directions. So for the next one here, 1 to the right, 1 up, 1 to the left, 1 down. If you'll let me do my point. And there's tangent. And we'll try to fit as many of these on here as we can. There we go. So 1 to the right, 1 up, 1 to the left, 1 down. There's the curve. 1 to the right, 1 up. Kind of fit it just off the grid. There we go. And this is going to go forever in both directions. This is the graph of tangent. And I do have to go ahead and stop very quickly and apologize to you. I am incredibly embarrassed. I didn't know my tan line was showing. Okay, all right. All right. So, questions. about how I got that graph. Now, here's what you might be wondering. Well, why in the world, how did you possibly know that we had, like, for example, those 3 points on one of these branches? Well, I'm glad that you asked. Okay. Let me come on over here. Let me show you the unit circle. Okay? In fact, let me go ahead and kind of set this up. I don't think I set that up very well. Let's look at this one period here. So it starts at negative pi over 2. Okay. I've got negative pi over 4, 0, pi over 4, and then it goes to pi over 2. Well, if you take a look over here, I've got tangent ready to evaluate at all of those radians in that one period. Okay. So let's go ahead and try some of these. The only thing is, what was tangent's ratio again? I always forget. It's y over x. So let's try this first one. Tangent of a negative pi over 2. Well, because it's negative, I'm going to have to rotate clockwise. Okay. So it's going to be right here. So negative pi over 2 is going to be coterminal with 3 pi over 2. But even though I'm not able to create a triangle, I've got an x and I've got a y. Well, let's see. The y value is negative 1. The x value is 0. What can we not divide by? 0. So see, that's why we have an asymptote there. There are locations where we can't evaluate it. Well, let's try negative pi over 4. See what happens. Okay. So I'm going to rotate negative pi over 4. So this is going to be coterminal with 7 pi over 4. Okay. Now, we could create a right triangle, but we've already got the x and the y values in front of us. So the y is a negative root 2 over 2. X is a root 2 over 2. So I'm taking a value and dividing by its opposite. What do I get? Negative 1. The ordered pairs are still created the same way. Okay. The x value is your angle measure, and the y value is your ratio. See, that's why we have the ordered pair, negative pi over 4, negative 1. Okay. Let's try one more of these. Okay. Let's try tangent of 0. Okay, so here is 0. We don't have to rotate it all. Here's the x, here's the y. It's y divided by x. So this would be y is 0, x is 1. What's 0 divided by 1? 0. So see, if I plug in 0 radians, I'm going to get a ratio of 0. Okay. So any point that we labeled or created on that graph, we could confirm it with the unit circle. Okay. Everybody okay with that? Does anybody have any questions? Okay. Cool. Well, we got some characteristics when it comes to tangent. We'll go ahead. Z keeps erasing. Okay. Now think about it. If this graph continues forever in both directions, if it's infinitely wide, how many x-intercepts am I going to have? We're going to have an infinite number. How many asymptotes? We're going to have an infinite number. So just like when we had with sine and cosine, that's why we have these little expressions, these little formulas that will help me find whatever asymptote or x-intercept I want. Now they do it in multiples of k, where k is a integer. Okay. So we also know that this is an odd function. It's symmetric with the origin. Remember, that means it has rotational symmetry. So if I took that picture right there, if I just flip it 180 degrees, not even a full rotation, it looks exactly the same. That's an odd function. Okay. It's infinitely tall, so the range is from negative to positive infinity. The y-intercept is at 0, 0. And then you'll notice the asymptotes, it's the same expression for the domain, because the domain is all reals except the locations of those asymptotes. Those are what we have to throw out. Okay. So there's one more thing I want to show you about tangent, and then we're going to get to the homework. Okay. So any questions so far? How are we doing? Cool. Okay. Well, you remember how when we're trying to graph sine and cosine, we start horizontally between 0 and 2 pi? And then vertically, we have to have a certain combination of zeros, ones, and negative ones. Okay. We're running with the same idea, but when it comes to tangent, this is what we're going to have to do. Horizontally, we need new boundaries. So we're going to go from negative pi over 2 to pi over 2. vertically, we're going to use these. And you remember the no solution symbol? That was meant to represent what? An asymptote. So we're going to say asymptote, -1, 0, 1, asymptote. In fact, what are negative pi over 2 and pi over 2 to tangent? They're asymptotes. So you'll notice we don't have equality any longer. Okay? You can't include the asymptote because it's undefined there. So we're going to do the same thing. We're going to start with this information, but we're still going to create a table of 5 values, and then we're going to go ahead and sketch it. Okay? Now, we won't see our first one until tomorrow, because I want to get to, like I said, to that assignment. Okay? But why are we doing it the way we are? Okay, well, I'm glad you asked. If we come back over here to the graph, you'll notice between negative pi over 2 and pi over 2, that's one what? Especially p. That's one period. Remember, horizontally, we're using that compound inequality to figure out where the new period is going to be. And then we went from, here's what we had vertically. We said the asymptote, -1, 0, 1, asymptote. Okay. Well, look at this period. We're starting with an asymptote, right? What's the y value of this location? -1. The y value? 0. The y value? 1. And then we have our asymptote. So does it make a little more sense why we have those particular values? See, tangent is really different from sine and cosine, so we can't use the same information. Okay. How we doing? Fantastic. Okay, so let me go ahead, put this to the side. We don't need that. Okay, so the rest of our time is just going to be looking at the homework. Yes. Give me back. Okay. All right. Now, I'll go ahead and tell you, because other classes have asked me about this. So tomorrow on the quiz, there's going to be 3 questions. 2 are College Board, but 1 is going to be like these. Okay. Like these problems right here. So you're going to be given a sinusoidal function. You're going to find me all the characteristics. You're going to fill in the table, and then you're going to go ahead and sketch that. Okay, so number 1 is going to be the biggest problem on the quiz tomorrow. Okay. All right. So with that in mind, what are we looking at? Yes, but which problem? Yes. 10. Let's do 10. Okay. Now, the only thing I'm going to go ahead and add here is the frequency. Okay. So we're given negative cosine of 2 times x minus pi over 2, and that's it. So here's the thing. We have A. We have B. What's D in this case? 0. So this would be the same as if I were to add or subtract 0. So in this case, there is no vertical shift. D equals 0. Okay. Now, for this, the way it's written, that pi over 2, that is your phase shift. That is actually how far you're shifting. Okay. Now, when it comes to the characteristics, the phase shift, I want you to give me 2 things. How far are we moving horizontally, and what direction? So I know that I'm moving pi over 2 units. Remember, the expression is C over B, but we're moving pi over 2. Is this right or left? Wait, it says minus. Why is it right? When you add or subtract to x, you take the opposite. So this is going to go to the right. Now, you don't have to give me that little expression, the little formula, but you do have to tell me how far we're shifting and in what direction. Okay. All right. Now, if I actually wanted to know what C looks like, well, then I would just take that 2 and distribute. So this would be negative cosine of 2x minus pi. That's a horrible 2. I can do better. Okay. Because see, 2 times pi over 2, the 2's cancel. And then I'll go ahead and still put the plus 0 there. So we've still got an A, we've still got a B, we've got a D, but now I actually have the value of C. Okay. So there is a difference in how it could be written. Okay. and you actually see what your phase shift is. That's exactly right. Okay. So let's see here. The amplitude was the absolute value of A. Well, what's A? A is a -1. Would everybody agree? So the absolute value of a -1, well, that's just 1. So all that's telling me is that there's no vertical dilation. There is a reflection, okay? Just no vertical dilation. The period, that was 2 pi divided by B. What's B? B is 2. So 2 pi over 2, yeah. So it's just pi radians. There we go. Now for the midline, there's something else you're going to have to give me. What's the value of D? 0. Now there is no vertical shift, but you can't just go ahead and say 0. You have to give me the equation. So y equals 0, because it is a horizontal line. So I've got points tied to the equation, the value, how far you're shifting, and what direction. Okay. So it's not a lot of points, but remember they can add up. Okay. You definitely want as many as you can get. Okay. And then the frequency, we just saw that a moment ago. That's just the reciprocal of the period, b over 2 pi. Okay. Well, in this case here, what's the reciprocal of pi? 1 over pi. So what is that actually telling me? How many times is it going to repeat? It should repeat once every pi radians. There we go. So right there, that's already a third of problem 1. Just like that. Any questions? Anybody lost? Okay. Now the next part, we're going to move on to our table. I'll just use this table up here because that way I don't have to go back up and down. Okay. Let's see here. We're out of here at 4 after. Oh, we got plenty of time. Okay. So let's see here. Now that we're graphing cosine, this is where we're back to what we were doing last week. So I'm going to go ahead and say 0 is less than or equal to 2 pi. Okay, now remember, horizontally, whatever's in the parentheses, that's what you're going to put in the middle of this. Okay. So I'm going to come on over here. I'm going to go ahead and use this. I'm going to say 2x minus pi. But here's the thing. What if I'd put 2 and then parentheses x minus pi over 2 parentheses? I still would have gotten the exact same thing. Dealer's choice, whatever you want to use. Okay. So I need to get x all by its lonesome. How do I do that? Okay, so let's start by adding pi. Plus pi, plus pi, plus pi. Okay, so pi is less than or equal to, now I've got 2x is less than or equal to 3 pi. Okay, now what? Now we'll divide by 2. So it looks like pi over 2 is less than or equal to x, which is less than or equal to 3 pi over 2. So what you've got here, this is now going to be a new period for your graph. We're going to see one repetition, one cycle from pi over 2 to 3 pi over 2. Okay. All right. So now, this lower boundary, that now becomes your first x. The upper boundary, that becomes your last x. Okay. So, Soren, how does this help me fill in the top row, though? What do I do with these two boundaries? Well, we got to take 3 pi over 2 and pi over 2, and there's two things we got to do with them. Anybody help me out, James? There we go. So first thing we got to do is subtract. So it's always the upper minus the lower boundary. And then whatever that difference is, always, always, always divide by 4. Okay. Well, these already have a common denominator. 3 pi over 2 minus pi over 2, that's going to give me 2 pi over 2. So that's just pi over 4. So this is the horizontal distance I need between the points that I'm creating. Remember, these graphs are periodic. They're going to repeat over and over again forever. Okay. All right, so Rami, how does this help me do that now? Okay, so I just start adding. So plus pi over 4, plus pi over 4, plus pi over 4, over and over again, whatever that value is that you get. Okay. Let's see here. So I need a pi over 2 plus a pi over 4. Okay, so that's going to be 3 pi over 4 plus pi over 4 plus pi over 4. And then 5 pi over 4 plus pi over 4, that will give me 3 pi over 2. Does anybody want me to show some algebra, how I got those? Any takers? Okay, so we're halfway there now. What do I do for the y's? Okay, so I remember there were two sets of numbers. It was either 0, 1, 0, negative 1, 0. I really need to recalibrate this screen. Or it was going to be 1, 0, negative 1, 0, 1. What am I trying to graph? Cosine. So which one do I need? I need the bottom one. Remember, cosine starts with a maximum. If I were graphing sine, then I would have taken the top combination. Now, at this point, we've taken care of the horizontal. We don't have to worry about that at all. What's happening vertically? Ooh, there's not a shift. Just a reflection. So all I have to do is multiply these by what? Negative 1. So I'm going to have negative 1, 0, 1, 0, negative 1. Okay, that's it. So negative 1, 0, 1, 0, negative 1. There we go. Now we can just plot my points. This is the easiest part. Okay. I would say probably the most work you're going to have to do is filling out the table. We didn't seem to have too much issues with the characteristics. That seems okay with that. So let's see, pi over 2, negative 1. Then I have 3 pi over 4, 0. Then I got pi 1. Then I got 5 pi over 4, so 1 and 1/4 pi 0. And then I got 3 pi over 2, negative 1. Okay. And then it doesn't quite look like I'm going to be able to fit another period on there, but I can at least, fill this in a little more. And there we go. There is negative cosine of 2x minus pi, and then plus 0 if you want to put that on there. Aaron, let me go ahead and graph the midline, that y equals 0. Does that cut the graph horizontally in two? There you go. There you go. That is what your number 1 on the quiz tomorrow is going to look like. And then it's going to have 2 College Board questions after that, multiple choice. Okay. And who asked about number 10? Okay. Alex, does that make sense? Is that good? Okay. All right. Well, we don't get out of here till, what is it again? 12:04. So we still got plenty of time. Is there anything else? Oh, 20. I was actually wondering if anybody was going to ask about 20. That's that weird problem. Okay, so let's take a look. Now, questions 17, 18, and 20, where you have to write the function, okay, the equation for your graph, that is not showing up on the quiz tomorrow. In fact, next week, after we finish up our current lesson, that's our next lesson. We're going to hit that pretty hard. We're going to be with that for a while. Okay, so number 20. One day, all 308 million people in the U.S. climb up on tables and they jump off. Okay, the shock as we hit the Earth's surface starts the entire Earth vibrating in such a way that its surface first moves down from its normal position, moves up an equal distance above its normal, assuming the amplitude is 50, the displacement distance above and below the normal position of the surface will be a sinusoidal function of time with a period of 54 minutes. So we want to go ahead and sketch this. Now we're starting when the time is 0. So what do you think is going to be better here? Should I go with sine or cosine? Let's go with sine because it starts with the origin, right? Now remember, sine has a period that looks like that. Okay? But think about the scenario, this ridiculous scenario. If everybody in America gets up on a table, we all jump off at once, what happens to the ground? Whoa! The ground goes down 50 feet, comes back up to normal, goes up 50 feet, and comes back up to normal. Okay? So this goes up, though. So we're starting at the origin, so I'm needing a graph that goes down, comes up, and then goes back to normal. So I need it to look like that. Is everybody okay? Now, what I did was I went ahead and counted these tick marks by 6 because we got to be able to get to that 54-minute mark. So like this is 6, 12, 18, and I want to say 54 is right there. Let me double check to make sure that I'm at the right location. Yes, yes. All right. So let's go ahead and start to match up what I need here with what we know should happen. So we know that this first part right here has got to start at 0. Okay, so that's cool. Now, we need to go ahead and make sure that at the very end of the graph, it starts to repeat again at 54 minutes. Okay, so we're matching this up. Now, let's go ahead and start to break this apart. Because remember, these graphs are periodic. They're going to repeat. They have equal distance between them horizontally forever. So let's say this point right here, okay, what's halfway between 0 and 54? Okay, 27. So let's say if this is going to be 18, then that would be 24. So this one would be 30. So let's say 27 is going to be right about here. Okay. Now, this minimum value and this maximum value, they're each going to be exactly halfway between their respective points. So if this one right here we're saying is 27, what's half of 27? Okay, 13.5. Okay, but here's the thing. At 13.5, this is when the ground reaches its lowest point. How far down is the ground supposed to go? 50. Okay, so that's why vertically, I went ahead and counted these by 10s. Okay, so let's see. Let's go ahead and say that 13.5 is like right about here. I'm just kind of estimating. So negative 10, 20, 30, 40, 50. There we go. Is everybody seeing how I'm matching these points up to what my graph should look like? Is everybody okay with that? Okay. And then we got one more. Okay. So basically, we could take 27 and go ahead and add 13.5 because this distance will be exactly the same as that distance. But I'm just going to estimate this time. So 10, 20, 30, 40, 50. So let's say maybe about right here. Okay. So then when I go ahead and draw this, there we go. There's the curve that represents the ground going down 50 feet, coming up to normal, going up 50 feet, and then coming back to normal. You remember how I said that was a ridiculous problem? Just accept it and go with it? Yeah. Okay. All right, so there's part A. And then for part B, it says write an equation expressing the displacement in terms of time elapsed since the people jumped. Okay, well, we already used sine. Okay, so that's easy. What was the value of A? What was my vertical dilation? It was 50, but there you go. Remember, we had to flip it because the ground went down before it went back up. So we have to make that a negative 50. Now, let me ask you a question. It says that the period is 54 minutes. Does that mean that B equals 54? What do we think? No. The value of B is what we have to find. So I need some coefficient, okay, in here times X, that when I plug it into my period expression, it's going to give me 54. So I have to go ahead and create a little equation. So I know that 2 pi over B has got to give me 54. See, we got to work backwards to figure out what that value is going to be. Okay. So I'll just go ahead and put this over 1. How do we solve a proportion? We cross multiply. Okay, so this is going to give me 2 pi is equal to 54b. What do I do now? Divide by 54. Okay. So 2 pi over 54, but what's 2 54ths? 1 over 27. That's a 2 right there. Oh my goodness, this smartboard. I'm going to say, there we go. That should represent the curve that we just sketched. Negative 50 sine of pi over 27x. But like I said, numbers 17, 18, and this one where we have to do that, that is not showing up on the quiz tomorrow. Okay. It will be showing up on a super fun quiz in a couple of weeks. That's one of the, I'm excited about that one. I can tell you folks are too. Okay. All right. And Oliver, you asked about that one, sir. Is that good? Okay. I've got 11:59. Was there anything else? Ooh, we're on the last 5 minutes. Can we wait? Okay, because I'm afraid they're locking the doors right now in the last 5 minutes. Okay. I hate for you to get locked in there. Well, I got to get back to pre-cal. Help. You know. All right. Anything else? Yes. Number 12. I don't think, because number 12, if I remember correctly, that's one of those huge ones, right? Okay, I don't know that we'll have enough time to get through it, but maybe I can go ahead and get us started. Okay, let's take a look at this real quick. Okay, so negative 3 cosine of pi over 3 times theta plus 1 minus 2. Okay, so I've got an A, I got a B, I've got a D. That 1, is that my phase shift or is that C? That's my phase shift. We can only see C if B is distributed across. So that would be negative 3 times the cosine of pi over 3 theta plus pi over 3 and then minus 2. So now I still have an A, I've got a B, I've got a D, but now I have my C. Okay. See, it's really easy to forget, so we want to know which one gives me the phase shift and which one gives me what I'm looking for. Okay, so Lexi, what part of this was more confusing? Was it the characteristics or the table? The table? Okay. Specifically the y values? Okay, let's take a look. Now, because I'm graphing cosine, we're going to start with a maximum. And we have 0, -1, 0, 1. Okay. Now, remember, we're not looking in between the parentheses. That's horizontal. So the only thing happening outside, we've got a reflection, we've got a vertical stretch by 3, and then we've got a vertical shift. The whole graph is coming down 2. What am I going to do first to these values? Okay, what was that? Oh, there we go. I thought you said -2 for a second. I was like, I'm old. So you want to take care of, follow your order of operations. So if it's multiplication, that's what we're going to begin with. I'm going to start by multiplying these by -3. So that's going to be -3, 0, +3, 0, -3. So right there, I took care of both the reflection and the vertical dilation at the same time. Okay. Now what am I going to do to these values? Now we're going to subtract 2 from each other. So -2, -2, -2, -2, -2. So -3 minus 2, there's a -5. 0 minus 2, 3 minus 2, 0 minus 2, and then -3 minus 2. There we go. Now, if I were ready to go ahead and fill this in for the x's, I would say 0 is less than or equal to. And remember, you can put either of these in there that you want. I'm going to go ahead and say pi over 3 theta plus pi over 3 is less than or equal to 2 pi. Once you simplify those new boundaries, that's how you start filling in your x's. Okay. Does that help out? Fortunately, I apologize I wasn't able to get through that any further, but maybe If you come in tutorials, I can walk through the rest of it with you. Okay, cool. Okay, so let's see here. I do not believe. I did not. Okay. Yo. Yeah, I got called out.